got a full spare. I was going to say out there too. There's not a full spare that's getting warm. Try to set a precedent for all chairs.
You got power?
Got the lights on. Thank you, sir. You are.
Okay. We're in business. Sorry about starting a little bit late because we actually have a very full agenda. So my name is Aaron Falk. This is the Hotrfc Lightning Talk series. I'm happy that you all have come. This is, I think, the fourth or maybe fifth time that we've run this. The idea of this session is to have a series of introductory talks to give folks who are doing something new in the IETF a way to get the word out. And so it's especially good for things that cross areas or are new to the IETF, maybe coming in from the IRTF. Or BOFs, that sort of thing, to just give a very short synopsis with some coordinates on how to get involved or learn more if you're interested. We have about 22 talks tonight, so we've got a very full agenda. Still should come in under the 2-hour slot, so if you've made dinner plans, I think you'll still be able to make them. But the way that we're going to do that is through very strict time limits. So we're using the Larsager time management method. And so at the end of 4 minutes, if the speaker hasn't concluded, you should hear this sound. At which point I'd like everybody in the room to start clapping and thank our speaker. Very good. Guys have got the right idea. Now, all of it comes down to my ability to push the button correctly. Let's see. On the materials site, you should find all of the slides that you're going to see tonight, as well as abstracts that summarize the talks and include the coordinates for finding out more information. So there's not going to be any time for a Q&A. It's really intended to be something that's very concise, give you the flavor of something new, move on to the next thing. I hope you find it interesting. And so, Brian, if you would come up, our first speaker, and I'll get your slides up.
Which button do I click to come?
I think the right button does it.
Okay, are we on? Have you pressed your button yet?
Not yet. Okay.
Okay, so on the left you see some users, on the right you see some services, and the objective of what we're talking about here is to discuss a new way of possibly connecting the users to services. I clicked and nothing happened. Thank you. What? No, I'm pointed over there probably. Anyway, why? End-to-end IP service is no longer a safe assumption in the internet. There will usually be middle boxes. Users want specific services. They don't want IP addresses or URLs. And ISPs want to provide some services, and they want to redirect the user to other services. That was the wrong one. Ah, that would explain. So what? Use the service type request and non-IP address to forward packets at the network edge. We're not talking about the core of the network. Abstract a service as something called a service action type, which is a small integer, indicating that service is a very generic idea. Near the user, the packets are routed by the service action type and not by the address. And of course, before you ask the obvious question, IP reachability is one of the available services, which is how it turns out to work backwards. So here are some examples of service action types: reachability on IPv6, reachability on IPv4, discovery service, computation service, a storage service, and there's a list of others in the draft. Packets are in the format derived from IPv6. This is a low-level protocol, but there's a service action type instead of a destination address because users don't care about destination addresses. And there are other goodies that look like a layer violation because actually this thing is intentionally a layer violation. There's some toy code that's probably not worth looking at. More important, there is a side meeting discussion on Wednesday morning, 8:30, not in the church, but in the room called Notre Dame. We're also discussing other drafts that I'm going to talk about in the second 4 minutes. And I'm done. Hello, it's me again with the same with the same co-authors. This is a bit more down to earth. Why are we talking about this? In edge deployments of IoT in particular, the physical MTU and the bit rate are in some cases extremely low. That's well known, so packet size matters a lot. The edge routers may be constrained themselves. That has other implications besides the problem of bandwidth and bit rate. Header compression and header decompression use resources. 128-bit addresses use memory. So for a certain class of routers, there is a strong case for both reducing packet size and reducing the header decompression and compression overhead. What? Well, you do it by using shorter addresses, routing on the shorter addresses, not transmitting unnecessary bytes, and avoiding any fancy compression and decompression algorithms at the level of processing the IP header. How? You define an address length n within a domain. All addresses within the domain are assumed to have a prefix in front of that of 128 minus n bits. And there's lots of bytes and headers that you can get rid of if you think about it. And we use a flexible header encoding octet to tell the lowest layer of software how the header has been encoded. So you might end up with a complete IPv6 header that consists of payload length, next header, hop limit, and the truncated destination address, because it turns out in the right conditions, all the other bits and pieces in the header aren't actually any use. And those are the bits that you expect this constrained router to look at. Where 6-slow working group on tomorrow, and same side meeting discussion in Notre Dame on Wednesday. The end.
Thank you very much. Before we go to our next speaker, I just want to let folks know that this session is being streamed live, and there's going to be video available on YouTube. So if you want to point somebody to this, there'll be YouTube coordinates in the usual spot. Okay. Our next speaker is Leo Bing.
Okay, hello everyone. Today I'm introducing a new technology called Instant Congestion Assessment Network. So what's a main target problem? First, the traffic in real networks, especially metro network, is always heavily unbalanced. Although we have ECMP or USMP, such kind of technologies, usually they don't really work very well. And second, the traffic is always changing so fast, and traditional traffic engineering technology cannot adapt the traffic in real time. So with the ICANN technology, we can provide guaranteed network load balance in real time, millisecond level, and as well as SLA assurance and high availability. These actually share the same core technology, but with different purposes. And for the use case one, the network load balance, we have already implemented a prototype based on commercial hardware router. And according to our test in the laboratory, the whole network throughput could be increased up to 30%, which is a really good result. And the basic principle of the ICANN technology is that we use the async controller to calculate multiple paths between each pair of ingress and egress router. And after that, the routers will, by themselves, adjust the flows between the multiple paths based on the continuous measurement of the path congestion situation. This is done in a very fast manner in millisecond level. So welcome to join the discussion with more details in TIERS and RTGWG. And you can also check the backup slides of this presentation. And please feel free to contact with me with any questions. Thanks.
Hi, so Adam and Bob and I are working with various international standard setting bodies and government agencies on a really critical problem. Go. Next slide, if you would, Bob. Yeah. So it's just this. A small unmanned air vehicle can very rapidly get close to a crowd or a piece of critical infrastructure without being observed en route. And some public safety person armed with only something that he's likely to be carrying needs to be able to quickly identify that thing. Is it a friend? Is it a foe? Can we look up its flight plan? Maybe can we establish communications with its operator and know for sure that it's the operator of that aircraft that we're talking with? This problem of mapping a physical location to a trustworthy identity seemed to me related to the identifier locator split in the internet, and where we're trying to go between a logical location and an identity. And so we're looking at the use of HIP to do this, and I'm going to let a HIP expert take the rest of the time.
Speaking with Stu and Adam, we've worked out the value of HITs as the remote ID for UAs. It provides a trustworthy identity to pair with physical and logical location data. As you know, HITs are valid IPv6 addresses can be used directly over the broadcast media if that's what you're transmitting, like Bluetooth. Bluetooth 5 is one of the PHYs for this, with provable ownership using the high for the signature. full mobility and multi-home support. So in case you're using multiple PHYs on this particular UA, which is supported, you can use the hip-based IPsec for secure communication if that's what you desire or need. And we can come up to a secure registration for the identity bootstrap on a first come, first own for the ID. That's what's available there. But it's not exactly what's needed for this case. There's some work needs to be done. The original design of HIP talked about hierarchical hits. I've done a draft on this since then, and because of ownership and other registry issues, hierarchical hits would definitely be of value for this. We need to have an expanded registration process of what's in the current documents in terms of a federated registration authorities to tie in the various metadata, the actual physical location, and ownership and other information about the device. Some of the new crypto support, which is out there, taking advantage of CBOR where appropriate. And since they keep on in the work talking OAuth, look at HIP as a whole OAuth method. That's what we've seen so far. There will be other work to be determined as we go through this process, but we feel that this is a very good fit of technology and a requirement situation. Oh, absolutely. And we have a side meeting scheduled for tomorrow afternoon during the PM3 time slot. And it's in room C2 for our side meeting. And there's a mailing list. That's right. And there's a mailing list, pm-rid@ietf.org, which was just set up today.
For the folks in the back, there are a few seats in the front and a few seats over against the wall over there if you are trying to get in and you need stuff. To the right arrow.
Hello, I'm Sharon from Nexar. I want to talk. Sharon from Nexar. I want to talk to you about a cool problem and RFC draft that solves it. It has to do with the sharing of physical information of on the road between cars, and it makes use of a grid of the Earth, hexagonal grid of the Earth called H3, and an overlay network which can make those tiles of the Earth addressable called Lisp. So just as a background on the problem, we distribute hundreds or thousands of cameras each week to drivers for them to drive around. They're paired with their phones. They do it because of insurance motivations, and the insurers want them to do that. But as a result, we actually have tens of thousands of eyes crawling the physical space and the public domain in every major US city. And because of the pairing to the phone, it's not just cameras. They actually understand what they see with AI, and they are connected using a network. So when we want all these mobility client agents roaming the streets to communicate what they see, the connected car industry had two options for us. One is an offline network. Tells about like a stop sign that fell or struck by a tree, or a construction zone which is in permit, out of permit, but it doesn't tell you if that construction cone is generating problems right now, or if that traffic sign is okay, but the traffic light is out right now. So there is a real-time network option, mostly for safety, but that's a peer-to-peer network. So for example, for safety situations, not for something that I'm about to hit right now, but something which, let's say I'm driving 100 kilometers an hour to a pileup or to a slowdown, or I'm turning a corner in a junction in a city to a double parked vehicle, an unloading vehicle, a tough situation for me to negotiate out of, and the cross traffic sees it clearly. There's no clear way for me to get that information. If the last car just drove away 3 seconds ago, I won't get the information, or I may get multiple and conflicting information from cars I don't know and I don't want to know. So the solution is to pack up all these annotations as you drive and assign it to a tile. That tile has an ID based on the location in the earth, but also it's translated to an EID, which is a Lisp address, which is now make it something I can send packets to. Got it. This addressing scheme allows me to share information between, let's say, mobility car going here, mobility car going there. This car sees this car's future, and vice versa. They can publish and subscribe to it. In tests, we were able to communicate a red light breach in under 4 milliseconds, a bit of a lab conditions between a camera on the junctions and all the cars approaching and affected by it. So if you're interested, it's discussed in the Lisp working group tomorrow, and happy to have more participants.
Hi, I'm Ronnie Evan, and I'll present the Open Congestion Control Architecture with Network Operation for RDMA Fabric. So, the motivation for this work is for data center that the high link speeds that are making network transfer complete faster in fewer RTTs. Short data bursts require low latency, while longer data transfer requires high throughput. So these are two requirements there. The RDMA is the common protocol in data center network. However, the congestion control is not optimized for different usage and lack interoperability. Allowing for flexibility in running an optimized congestion method in the network interface card and having fast congestion notification to the sender can improve the RDMA data transfer. It's common in the data center network that TCP traffic is mixed with the RDMA traffic and causes conflicts between priorities between them. And what we're saying is there a better method that could solve the problems mentioned above while addressing interoperability so that RDMA traffic can be treated more efficiently. So we have two documents on the open control architectures, the requirement document and the architecture document. The requirement discussed the problems of the current remote direct memory access fabric congestion handling technology and the requirement for better performance, and the architecture propose an open control architecture of host and networks for the high-performance RDMA fabric to provide better congestion handling for HPC and distributed storage application. The architecture itself is seen in this slide. There's the sender, the reaction point, and then the receiver is the notification point, but the switch can serve both as the congestion point, but also is the congestion point, but also can provide notification. So there's can be a net to NIC control channel, and of course the net NIC to NIC control channel that will provide the information to allow the sender to respond better and faster. So the design configuration is provide better information about the congestion state to the sender, faster and more accurate from the network, and notify the sender the reaction point from the network. It can support proactive response from the notification point and support RDMA transport, different RDMA transport. So this, what we are talking about is something that would be transport agnostic, and support multiplexed traffic of RDMA and TCP. We did already some experimental tests, and we are having a side meeting on tomorrow in Notre Dame room. And of course, if you want to discuss it with me, this is my coordinates. Thank you.
Hi, I'm Paul Congdon, and if we had coordinated better, I probably would have gone just before Ronnie because this is a very similar topic, but I'm kind of approaching it from a little bit of a more higher level, not a specific solution. Ronnie has some drafts that describe that solution. So I want to talk about strategies to dramatically improve congestion control in high-performance data centers. So first of all, data center congestion is different than the internet congestion. I think we all know that. A few handful of transactions can cause a lot, coming in from the web can cause a lot of activity inside a data center. So data centers have much different environment. There's different bandwidth delay. The switches are implemented different in small buffers, high speed links, than internet routers. There's a lot more homogeneity in the network design. It's not so random. The traffic is very concentrated. Servers and storage are all in close proximity. There's a lot of the traffic profiles are kind of well known, highly coordinated, correlated, and typically they're managed with a lot fewer people under a single management domain. So all this means that data center congestion, the environment in which it runs, is much different than the internet. And we know we do internet standards here, but we also do have focused on data center standards, like DC-TCP as an example. So the data center needs low latency, low overhead, high efficiency, and high throughput. So one thing the data center kind of has in common with the internet is there's this trend to do more over UDP, something like we've seen a lot of activity with QUIC, for example. So what if we, could do something that was more sort of QUIC-like, but not quick, as heavy, perhaps specific for the data center. And maybe we did something that was datagram congestion control like, but again, focused on the congestion problems of the internet, of the data center. It would need to be hardware offloadable, but maybe with less emphasis on security and crypto and all the threading kind of stuff that things have. It would need to be really common congestion control as described in the previous talk, and ideally it would need to have the network visibility, marking, and signaling abilities from the network itself. So the IETF has this expertise, so let's leverage it and not leave it to the UDP application writers. Let's see if we can do something. We know data center congestion is different. The authors of these papers have done a lot of work on congestion trees. So there's kind of two types, in network and in congestion, and it's constantly moving around in cast or in network. We've got solutions today such as ECMP, ECN, even in a lossless environment, ECN with priority flow control. All of these have various pros and cons, but they're not completely addressing the needs that we see. So some ideas of augmenting ECN with a data center focus for a UDP layer, providing more feedback from the switches in the packet headers, perhaps, marking delay inside packets so that we can get really fine-grained view of what's going on. Being able to figure out, is this congestion we're experiencing right now, is it in network or is it in cast? Because maybe we would take different approaches. Being able to speed up notifications to the source so they can quench in a way that addresses it. And then implementing fast mechanisms in the switch to respond immediately. So what I'd like to do is discuss the technical approach and feasibility of these ideas in a side meeting. So we have a side meeting tomorrow. Notre Dame is the same one that was announced, and we're also providing remote participation for that. And then we're going to be requesting a IETF mailing list as well. So I think I made it. We also have a whole bunch of references in this deck if you want to read them.
You're not going to read those. Thank you. Can you put that on the? Oh, yeah.
Thank you. For the folks in the back, there's room on the floor in the front if you guys want to sit down. So just saying.
Adrian.
Okay. You have yeah, okay. Thanks. Hi, I will present a work showing that we can leverage an existing network intelligence to build service function chain. In most of existing deployment, service function chains are controlled by a central control point, which compute the ideal placement of virtual functions such as the IDS firewall and the flow path that goes through them, raising some problems since it creates a single point of failure in the network, scalability issues. It's hardly interoperable with existing networks, and it underexploits the existing protocols running in the network. For instance, service function chaining problem is mainly a routing problem because you have to route traffic through a set of waypoints before reaching the destination. So what we propose is to augment classical entire gateway protocol and make them function aware in order to build service function path. I will quickly remind how entire gateway protocol functions. You have a gateway which are connecting to networks, sharing information, and building a network view, and based on that, it will compute routing tables. What we propose is to bind some prefix to specific functions such as firewall and IDS, allowing to use the routing protocol to route the function through, flow through the functions, and to use any castle things to use the IGP matrix to select the function instance. As a consequence, you have a logical network view, which is this one, where you have, for instance, the pink node, which represent, for instance, a firewall, and the two instances on the two routers will be different based on some matrix related to the instance. If you're interested in the work we are doing, you can come to a Connenger session on Thursday, and we can discuss about that. And you can also find some of our work we have presented in existing conferences if you want. Thank you.
Jeffrey from Huawei. So the purpose of this talk is to find the people share the same interest as with me to, about the theory behind the networking. So to clarify the terminology, theory is a system of ideas to explain based on general principles. So IETF is quite unique. We have many contributions from universities. And we even have a research arm, IETF. But in my personal view, there's still a gap in our networking area as a whole. So our innovation and design highly rely on experience. I don't find a well-defined body of knowledge or a set of approaches that can help us to make design choice and understand the trade-off behind those decisions. So I'm not the only one have this feeling. So this is a very interesting paper from Jennifer Rexford at Princeton University. She quoted some doubts from people inside and outside the networking community. So is networking a set of protocol acronyms or a heap of head formats, or we are just a big bunch of boxes? Of course, Jennifer defeated all these questions elegantly, but at the end of this paper, she also suggested that we can make the question we ask more precise and the way we answer them more rigorous. And maybe we can not so much value new problems over deep answers to existing questions. We need to encourage more thorough and complete and deeper research. So why IETF? So in one way, this theory can help IETF to explain and predict the outcomes from new design and facing new problems. And also, it can help us can help new generation to inherit and make their own contributions. So on the other way, why IETF can help. So we have both rich and very successful experience and expertise in theory. We have so many academic participants. So why now? Now we are facing some new requirements such as deterministic and bounded delay services. So we may require more theoretical analysis than before. So this is there's an example in IEEE. They proposed to apply network calculus, a kind of queuing theory, to the time-sensitive networking problem. So there are several useful references. Of course, there's in one way is in one hand is the mathematical foundations and tools, and on the other is the theory of design. Herbert Simon proposed a framework a long time ago. I don't think I have time to address the details, but if you are interested, contact us. me and my friend Geng Liang from China Mobile. Thank you.
Okay, this is about software management if you don't use these standards, which is really the entire software industry outside networking. So you know every company starts the same way. You write a little service, you start including more services to do your function, and then you learn about microservices. It becomes this, and of course you get this, and of course you need a management plane to make sense of this all. So for each one of those little boxes. This is what you have to do today. You have to scrape log files to find out if the service is acting incorrectly. You have to write some tool to generate config files, deliver it, bounce the service. Okay, sorry, thanks. If it has a REST API, you have to integrate with that. You find performance metrics any which way you can. And if it has a security model, you got to somehow integrate with that. So every single service you have to do this with. And if it looks like a lot of work, it is a lot of work, but a lot of companies are cheating because they're finding recipes on the internet to help them get a jump start, or they're only mapping the pieces that they think they need before they go into deployment. And this is a problem because they find out after deployment they forgot something. So clearly this is a lot of work, and the standards for Yang and RESTconf solve this entirely for the industry as a whole. And to give you an idea of the scope of this problem, Puppet Labs, they estimate there are now more people in the management plane than there are in the data plane. So more people writing software about software than the software itself, solving problems. So this is a very large problem. And so in 2015, I became aware of these standards and wrote a implementation of the Yang and the RESTconf specs in Go. I started there. So I wrote my first project was this bartender. And it has a Raspberry Pi and some relays and some pumps. And it's got a little interface to make, the animation worked. But I did implement it all in RESTconf. So there's a Yang model for the bartender, and you can assign a pump to a particular liquid. And even when you make your recipe, you're going through RESTconf. And it was really no special tools on the JavaScript to get this to work. RESTconf really is designed really well to make it palatable to the industry as a whole, which is what its design was. So, and I really like how RESTconf has different modules. So if Amazon published a Yang for Alexa skill, I could add that in, and all of a sudden you're saying, Alexa, make me a Mai Tai. So since then, I've used this in lots of different industries: IoT, schools, malware detection. The standards work really, really well. But of course, that's only so good. So when we've arrived is when I can tell, say, PagerDuty, which is a system for alerting you, to say, hey, Postgres, when there's a slow query, page me about it. And I didn't have to involve DevOps. I didn't have to program anything. And this is all possible with the standards, but none of these tools know about these standards or implementing those. So I'm really here to talk about this problem in the industry as a whole, see if this problem resonates with anybody. I realize IETF is concerned about networking, but there's definitely a bigger hole, and I estimate there are actually 10 million developers. This could actually help them out. So, and I'm one of those, because without these standards, if I'm using these standards in outside networking, it really doesn't really solve the bigger problem. So, like I said, if this resonates with you, reach out to me. There's no working groups on this, but maybe next IETF there could be. That's it.
Thank you.
If the IETF is about anything, it's about bringing Mai Tais into schools.
Hi everyone. I'm here to talk about Ethereum improvement proposals, and there's no time for introduction, so just jump in. So as you may know or may not, Ethereum is the second largest cryptocurrency just based on the market cap. There's possibly the number of developers and tools that are on that are the first and whole blockchain DLTs. Ethereum is a home for ENS, which is Ethereum Naming Service, which they're trying to do .eth-TLD and also do DNSSEC in the blockchain. Also for IPFS or decentralized file system applications, there are a lot of more apps there. So I'm mostly talking about looking at processes here. So Ethereum is one of the healthiest decentralized dev cycles amongst the blockchain and cryptocurrency projects, but it's yet far from perfect. Some of the historical challenges, like decentralization requires a non-hierarchical development cycle, and it's really hard. So they have this EIP, which is in Ethereum Improvement Proposals, which was inspired by Bitcoin Improvement Proposals, and that was inspired by PEP, Python Enhancement Proposals, which that also was inspired by IETF, Request for Comment. And there are some aspects that were dropped on this path. We don't know where exactly, but like security consideration section on EIP, it's not there. I'm really trying to add it back, and it's going to be added in the next month, probably. So there is some other process. This is like the process today. I'm going to go quickly on these, and the slides are there for more details. So after discussing in the forums and getting the community support, the EIP author would add this EIP there. So security consideration is missing there. We're trying to add it there. And then goes to a selected track. So the core track is actually the consensus protocol, and the protocol, it's a really critical one. It has resulted in forks in the network and a lot of controversy. There are some others that like ERC, if you have heard of tokens, security tokens, ERC20, they're all in this track. And there are some other things. So the process itself has like 4, or you could say 5 steps. So when it gets the community support, it gets to the work in progress draft, and basically they write this. It should be matured, and if it's a core EIP, it needs implementation. They basically talk about it. It talks about the proof of concept. After that, it is assigned the EIP number, and it goes to a draft mode. Here, the EIP author would discuss and further mature the draft to have in a way that it actually makes sense and it has some more support. And after that, it goes to the last call. This process, every iteration takes around 2 weeks, and it actually ends up with a call, like a conference call. So here, mainly they talk about if there are any security implementations that needed to be checked. Here, mainly on tests, and it's more on a non-official one. And after that, if it's a core EIP gets accepted, and all the clients, at least 3 of the clients, there are like 4 or 5 Ethereum clients, need to implement that to get that actually in a final state. If it's not core, then sometimes it's standard. It just goes to the public, to final state. So this is overall what I just talked about. And this is the first attempt, as far as we know, to visualize this and have something to show that this is the process. Usually, and still, even with this process, it happens on GitHub. The proposals, PR, pull requests, everything happens there. There's this forum, Ethereum Magicians, that people discuss there, and your magicians there for the EIP magician, and also this is the call. This is like a core dev call that actually the decisions happen there. So why am I talking about this? So I've been involved in IETF process. We need the IETF people to find the gaps and missing pieces in this process and refine modules. I'm open to any discussions and comments, and this is how you can reach me, and I would be happy to talk about anything about blockchain here. Well, so,
Hello, everyone. My name is Qingwu. I'm from Huawei. I'm here to discuss what's the next step of Yang in IETF. Actually, a little bit of background from me. I used to chair L3SM, L2SM in Ops area, who deliver Yang data model for L3 VPN. And actually, we witnessed the Yang takeoff and flourish, but we still feel there's some problems. So that's why I bring this topic here. And so Yang data model get a lot of traction. Actually, operator began to plan to deploy the Yang data model, and but the reason for that, actually, Yang actually not only help you to automate the network, but also allow operator to build the more agile service. Yang actually can model the service from the top, and also allow you to model the configuration operation of the device allow you to configure the protocol on the device, get a network set up. So usually the young data model, you will classify them into service layer model and device level model. But also in the between, we have resource level model. They allow you to schedule resources to meet the service requirements from the top, and also allow you to program the network, actually make it adapt to network change. And so right now in IETF, more than 260 young data model actually has been developed in IETF, and more than 50 Hotrfc, and including 80 young data model. And we also see actually more than 100 young data model working group job that be proceeded in IETF. So we have so many young data model, and but the problem actually is we can reference the INTAG multi-vendor interoperability test report. We can see actually NetConf has widely adopted, but for young data model still at the early adoption stage. So what's the reason behind? So we see actually because the many operators actually not engaging in IETF for this young data model development. Actually, for some operator who already deploy this kind of technology may not aware IETF develop this young data model. Even for the operator who actually know what IETF is doing, but they don't know how this young model put together to deliver service to fulfill the service actually. So there's a critical gap actually. They will lead the IETF young data model actually like sufficient input from the operator. So to address this, actually, one of the approach we propose, actually, we can define young data model framework, actually to help operator to how to integrate a young data model in the same namespace. And so we have a draft actually posted in the OPSA-WG that will be discussed in OPSA-WG session on Wednesday. And this draft actually we work together with the operator, try to fill this gap to help operator to provide such guideline how to figure out how different layer model can put together. And in addition, we think standard work is not enough. For some of these, you may rely on more coordination between the okay.
Okay, I'm Philhan Baker, and this is the mathematical mesh. Oh, so internet security is broken. It's broken because users are finding security is just too much effort, and you can't solve that by asking them to try harder. It's broken because applications are not solving the real problem. I mean, like, look at all the data breaches, the data at rest breaches. We mostly focus on transport. And we've not actually changed our approach very much since the PGP days and the PEM days. We're still using the same toolbox, and we're still using the same limited number of operations. So the mesh addresses three core problems. Device management, so you can glue all your devices together so they're one gestalt. Contact management, so you can connect all the people that you connect to together and have access to all their public keys on all your devices. And a secure control plane messaging, which is end-to-end secure and traffic analysis resistant. Wrong. So it's based on the principle of, I'm using more advanced cryptography than in Bruce Schneier's book. One key cryptography is great, DES. You can do a lot with DES, but two key is better because you can separate out the roles of encryption and decryption. If one is good and two is better, why don't we try 3, 4, 5? Separate the roles out more and we can do more cryptography. And more cryptography means more security, yes. There's a bunch of small, powerful concepts here. I can't go through these at all, but basically there's 5 basic technologies here, and it's a grab bag, and they're all designed to work together, but you can also use them a la carte in your projects. Going to be talking about this at Sex Dispatch tomorrow at 1:30, and this is the wrong set of slides, it seems I sent in. I'm about to start releasing this, so if you've got strong opinions on it, please talk to me before I release it, because the minute I have users, I'm going to start protecting legacy and code. If you want to change anything, talk before I release the code. There's a whole bunch of drafts, and the drafts are based on running code that comes from the reference library. It's all in MIT license, all C#, all that good stuff. And the objective here is to provide people with kind of like a scikit-learn for cryptography. If you look at the advance in AI that's happened over the past 10 years, that happened after the AI people made it really easy for people to add AI into application with things like pandas and scikit-learn. So the reference code is an attempt to do that's the same thing for cryptography. And you've got all the same goodness of blockchain, PKCS7, PGP, X509, and so on, but in a much smaller library. Because if you make all the systems use the same unified approach, you can get rid of a lot of code. I've got rid of 2/3 of the code over the past 2 years. So meet up. So we're going to be talking about Sex Dispatch tomorrow at 1:30. Please be there or talk to me afterwards. Thank you.
You want to upload revised slides?
I'll upload the... Oh, and there's also going to be podcasts explaining each part of this on the web.
Hi, I'm Igor Lubashev, and I really want to talk to you about packet loss detection in encrypted protocols. I'm looking at quick. All right, I'm a transport guy. I love to think of my networks as just dumb pipes. But really, for them to be dumb pipes, there should be somebody inside that pipe who is looking for leaks and can find and patch them quickly. If it's seeing a TCP flow in that pipe, it's pretty good. He can look at sequence numbers, ACK numbers, figure out if there is leak, see if it's upstream, downstream. If he is looking at a quick flow, not as good. There is no bits to look at to see if there is packet loss. So I think it's a problem. And we propose a solution that uses 2 bits. 1 bit is a qubit, stands for square signal. It's very simple. Send, let's n, send 64. When you're sending packets, 64 of them have 0 qubit, 64 1, 64 0, so forth. The other bit is an L for loss event bit, and it is set when there is a special unreported loss counter which is greater than 0, and unreported loss counter is maintained by the sender. When there is a packet that the sender sent and the sender deems it lost, it increments the counter. When the packet with L1 is sent, the counter is decremented. So if you can see the picture, there are 2 packets in red. They've been lost. About 1 RTT to 1 RTO later, sender determined they've been lost, and it sent 2 packets with L1. Okay, how can we use that? How is it useful? So end-to-end loss is pretty simple. It's just a fraction of packets with L equals 1 bits that observer observed. Upstream loss is basically how many bits with a particular Q value are missing from a block. Once you have downstream and upstream loss, you can figure out, once you have end-to-end and upstream loss, you can figure out the downstream loss. Pretty cool. So it's cool in theory, but we decided to test it in practice. Akamai has implemented a scheme based on this in our deployed servers, and we've been serving quick traffic to some Orange end users in a number of countries for some time, and there is data for it, actually, real world data, not simulator or anything else. And that's plenty. And if you're interested, I hope you are, but if you're interested, if you're an operator or have thoughts about it, please see us. We'll be here Monday, tomorrow, 8:30 to 9:30 for a side meeting, and we'll talk about it in VWG on Thursday. That's going to be focused on protocol details as well as privacy and ossification risk. And then on Friday in MapRG, we'll actually present lots and lots of data and talk about it. And of course, you can talk to us. Thanks.
Rodney.
I'm Rod, and I want to talk about zero is not must be zero, or reserved is not must be zero. We all know about these common words that are used throughout our RFCs. There's a word I'd like to add to that list, and that's the word reserved, because it is interpreted differently at times. It's frequently used. It's poorly documented. There's differing ideas of exactly what it means and how it's used depending on in what context it's used. This is become a problem when reserved is treated as must be zero by a receiver, and some future thing has come along and go, that's not reserved anymore, I want to use that for something else, and somebody goes, nope, that must be zero, we're going to throw that packet away, it's no good. We're repeatedly running into this problem in protocol implementations, in software, in almost anything that uses the word reserved. So I'm basically trying to bring the idea that we might want to clearly define this, clearly define the different contexts that it can be used in and what it means in those contexts. This is going to be a 1-minute talk. If there's any future discussion, if people want to try and talk about, let's codify this, let's make an RFC out of it, I'm available. I'll be here all week. There's my email address. I've got a couple minutes. If anybody wants to throw anything out about it right now, we can. Do it. Do it? Can I hear a second on that motion? Should I start a draft?
Yes.
Okay, that's what I wanted to hear. Thank you.
Thank you, Rodney.
Hit one, enter. First slide. Just hit one. Hit enter. It's a quick way to jump to a slide number. Hello, everyone. My name is Stuart Cheshire. As some of you may know, I'm the creator of Zero Configuration Networking and DNS Service Discovery and what Apple calls Bonjour. I'm sure everybody knows it's used widely in Apple products. What a lot of people don't realize is it's now in most Linux distributions, it's used by Chromecast, it's on Android, and it's starting Windows 10, it's even in Microsoft Windows. Anywhere in your software that you have somewhere for a user to type in an IP address or a host name, you can use DNS Service Discovery to give them a list of options to choose from instead. If you have iPhones here, you can tap on AirPrint, and you pick the printer you want. There's nowhere to type an IP address. If the thing you want doesn't show up, you fix that by fixing the network, not by typing in IP addresses on the client devices. Traditionally, this is used peer-to-peer multicast. What's great about that is it requires no infrastructure. Just hook up two laptops with an Ethernet cable, no switch, they can discover each other. Two phones using peer-to-peer Wi-Fi, no access points, they can discover each other's services. That's great for small networks, but it's inefficient on large networks because it impacts every device on the network, even the ones you're not talking to right now. It's slow on Wi-Fi because multicast is sent at a low rate and multicasts are batched with the beacon, so there's high latency. It's wasteful of shared wireless spectrum, and it's unreliable because it's not acknowledged, so you have to retransmit, which makes it even more wasteful of that precious wireless spectrum with these slow transmissions. So we want to discover things that are multiple hops away without flooding the multicast. And if you do this with your iPhone today, you send a multicast, but the printer's not nearby. We solve that by adding a discovery proxy. Your device now makes a TCP connection by sending IP packets, multiple hops through that network. The discovery proxy can then do the multicast on your behalf and send the answer back. You discover the printer. You can now make an end-to-end TCP connection and use that. We'd love you to get involved. You can join the DNSSD mailing list. You can check out the code from the IETF hackathon. We have an OpenWRT package for this little OpenWRT router. In about 5 minutes, you can add a discovery proxy to this and have one running on your own home network. We'll be showing this at the Hack Demo Happy Hour tomorrow, just across over there, so you can come and see it working for yourself. And of course, come to our DNSSD working group meeting on Thursday. Thank you.
Shuping from Huawei. Today I'm going to introduce you one of our new work. It's application-aware IPv6 networking. So first, about the motivation. As the internet evolves, we could say we have already experienced all IP the first generation, but there are still some challenges. For example, the isolated network islands, or the limited programmability, and most importantly, and the network is still on its own, and the application and the network are isolated, are decoupled. And now we have SRv6. We could say we are entering a new generation, or IP, the second generation. And SRv6 has its own mission. And first, it is based on IPv6. So it has the affinity to IP. So it could be much easier to integrate the network domains. And also it has the programmability. So it has the programmable fields. So you could convey more information from the applications to the network. So in that case, you could integrate the application and the network, make them to work together. So here are the IPv6 extension headers. We have the hop by hop and destination options headers, and also the routing header. SRH is one of these. So we have the arguments fields and also the TRV we could use to convey some information from the applications. And that are the foundations for the application-aware IPv6 or SRv6 networking. We call it APN6. So basically, we are actually make use of the IPv6 extension headers to convey some information from the applications into the network. So the network could make the fine granular traffic operations to do the, for example, the network resource adjustment to guarantee the SLA. So it could be applied to, for example, the fixed mobile broadband, like the 2B, 2C scenarios, and also the mobile broadband. And for the solution side, we could have the host side solution. That is, the application directly put the information into the IPv6 headers, or it could be the network side solutions. That is, the network edge could detect the application and provide the information about the application and convey it into the network. And we are going to have a side meeting on Thursday morning, and we have the agenda. You could refer the related drafts we listed in the side meeting wiki. Okay, thank you.
We're on the backup USB stick. I don't know why. Sorry? Okay. Yep. Great. My name is Joseph Potvin. I'm Executive Director for X Algorithms Foundation. Some colleagues and I have initiated a project called An Internet of Rules. I'll say right away, if you think it's a terrible name that we should not be calling what we're doing that, please let us know. I'll restrict this to the why and the what of what we're doing. I could explain how there's running code behind this. We're doing alpha testing right now, but I've had very interesting conversations over the last 2 days as part of the hackathon, and there's lots of different ideas about and good ideas about how to do this. Next. So very happy to see what Rodney was talking about a few sessions here ago. We're actually working on the generalization of how words like must not, required, shall, and so forth actually get deployed. So if you can imagine any IoT implementation, and let's say there's some court decision in some province or state, and that's going to affect privacy rules in terms of how data moves around from and to all sorts of IoT devices, exactly how is that new rule going to get deployed? You could even say, oh, it's going to get deployed through the equipment providers. How is even that rule expressed in, say, English or Spanish going to get deployed to the 45,000 suppliers of these IoT devices? This affects issues in money, finance, commerce, tax, international trade, machine control systems, internet-based networking, whatever it is. The gap in this space is so huge, it's hard to see. So it's hard to communicate this sometimes because most people are looking for little gaps. This is an enormous gap. Next. So the problem is enormously wasteful, error-prone redundancy. Each of you who is not from Canada, when you pay your hotel bill right now, you're actually supposed to be zero rated on the value-added tax, but you're going to pay it. And if you were to try to claim it back on the way out, good luck to you. Little rules like that come in, and they are just simply not deployable today. That's tax, but any of these other domains, you have the same kind of problem. It requires a domain-specific language, which we've prototyped right now, or not prototyped, we've actually implemented at Alpha, and an optimized algorithm search. We're not dealing with if-then statements. We're dealing with given X facts as a context, when there's an input fact for a circumstance, then Z ought to be the case. So these are just 3 facts. Next. The actual software we have deployed begins by interacting with an API. There's a small component piece, an auxiliary piece called Lichen. You can use it or not use it. It's a reference implementation. Create your own if you like. Roll your own. That provides the context fact and the input fact out to the server. In the server is a distributed set of servers with the collection of algorithms which implement the rules. And these algorithms are simple, declarative, tabular or tuple-oriented programs. We deliver those back as output facts. We do not inject them. We stop at the point of delivering back the fact that there is a rule, and here's what it is. And next, please. So Xalgo, the domain-specific language, it's think of programming in terms of control tables, decision tables, and so forth, with a few reserved words. Very, very minimalist. It's deliberately not Turing complete, and it uses any standard schema when it comes to identifying what industry it is, what jurisdiction it is, what product type it is. Next, please. Intro Libre. Sorry? Out of time? Okay. That's the search engine. And then next slide. I'm presenting in this room on Tuesday, 8:30.
Thank you. Sorry about the confusion on the slides.
If we're working again?
Yes, but now I can't get to the slide.
Hi. So I'm going to talk a little bit about multiple provisioning domains, a term that you've probably heard and maybe know what it means, but I think a lot of people don't, so hence the talk. So the point of this is back in the 1990s, you had a host. It was probably sitting on your desk. It was connected to a network. It got DNS and IP addresses somehow from the network, and everything just worked. That was great. Good times. Times have changed, and so recently, and certainly in the 20-teens and even before that, it was not uncommon to have a host connected to more than one network. Typical scenarios, VPN is a classic typical scenario, but a less well understood scenario is when you have a host that's connected, say a phone, for example, that's connected to your cell service provider and to a wireless network, which may have a captive portal on it. You don't want your network service to suddenly stop because you're connected to the captive portal network. So things get a little more complicated when you have to deal with use cases like this. That's a typo. But anyway, so the host. So if a host looks up a service using the DNS server that it got from network A, and then tries to use the answer it got on network B, if that service is actually only reachable on network A, it's going to fail. So we need to be able to associate networks. We need to be able to associate things like DNS servers and IP prefixes together. And of course, in the 2020s, things are even more exciting. This is starting now, but you can see there are routers that you can buy that have both a connector for your ISP and also a cellular backup. And you'd like that to be able to work. And you'd also like your devices on the home network to be able to distinguish between the two providers. So how do you do that? The answer is with provisioning domains. So a provisioning domain is a collection of configuration information that's known to have come from the same source. So in the previous example, where we had network A and network B, network A and network B were both different provisioning domains. And similarly, in the 2020s example, where we've got provider A and provider B, those are both also different provisioning domains. So how do we communicate with this to the host? In the 2010s, usually we would just notice that we had two network interfaces, and so we would be able to set up an ad hoc provisioning domain. We would just assume that information that we got on interface A and information that we got on interface B are not interchangeable, and we would just do that automatically without being told. That doesn't work so well if you have a border router and you're behind the border router, and the border router is connected to two different homes. So in that case, we need something called an explicit provisioning domain. And so work has been going on in the IETF recently to make explicit provisioning domains happen. So the original
work was done in the MIF working group, and we produced a document called the multiple provisioning domain architecture, which explained the problem that I just explained to you in quite a bit more detail and more accuracy, but didn't actually solve it. And then just recently, a number of folks in the int area working group have been working on a document called Draft Int Area Provisioning Domains, discovering provisioning domain names and data. So this is using an RA option to explicitly state that this prefix and all of the information about this prefix is in its own provisioning domain, which has this name. So that work is almost done. I'm mostly telling you about this because I think it's really useful and you ought to know. Please come to int area.
Spencer. Spencer? Oh, there he is.
So Spencer Dawkins, and talking a little bit about performance implication of path characteristics. This is a Rube Goldberg machine, which actually turns out to be a pretty good implementation of what I think a lot of network paths look like these days. So how we got here, we did a follow-on to the TCP over satellite working group in 1997 to 2000, talking about very long RTT interaction with slow loss recovery. I brought a proposal for TCP over cellular to the IETF, and the AD suggested a structured approach instead of doing TCP over foo links. Aaron and I co-chaired the PILC working group 1999 to 2004, and we had specific recommendations that we issued as BCPs, most of them, for specific link characteristics. And that was adopted actually by Web Forum version 2. Life was good for a while. Things have probably changed since 2004. A lot of stuff is on here. There's actually probably more things that have changed that that I didn't put on the slide. Things like CDNs and stuff like that. But you know, a lot has been going on. I mean, just to pick one of them, we weren't thinking about multipath at all. We were thrilled we could get one path to work. So what I'd like to do at IETF 105, we had a side meeting at IETF 104 in the Code Lounge, and that was helpful. So I was going to schedule another one of those meetings. But I've also been active in the PanRG research group, and they've been thinking about path-aware networking. I'd like to talk to them about what is engineering and what is research. So what's ready for the IETF to make recommendations for, and what's not ready for the IETF to make recommendations for. And that's when PanRG is meeting. The thing, you know, so like I say, the thing that I'm saying here that I need to make pretty clear is that I'm talking about producing BCPs for protocol designers because we still get a lot of proposals from people who are trying to solve specific problems with well-meaning ideas that the transport community has identified problems with a long time ago. But we never write those things down. My favorite one was, you know, if you read my PhD dissertation from 10 years ago, you would clearly see that, and that was the best. Recommendation we had. I think the IETF has done better in the past. I think we could do better. Hope to see you on Wednesday morning and Thursday afternoon.
Thank you, Spencer. So for those of you not keeping track, we're down to the last 3 talks. If you're thinking about dinner, maybe I'm a little bit hungry, we should be out of here in about 15 minutes, so you can start making your plans. But our next speaker is Yi Zhao to talk about loops.
It's all right.
I only have a single page. Yeah. So we should finish with much lesser than 50 minutes. I only have a single page here. I'm gonna give a simple announcement on the loops BOF because this is one of the very first sessions of IETF. So I want you guys who were possibly just here and with your jet lag aware that this time the session starts from 10. Okay, so tomorrow morning, 10 o'clock, we are going to have the BOF loops, which stands for the local optimization on path segments. Give a very simple description. The path of a long-haul network can be naturally or purposely partitioned into multiple segments via possibly like a tunnel stitching. So loops aims to provide loss recovery locally over some specific segments. So that's the basic idea of loops. So here are 2 pointers of the drafts. So please read them and please join us tomorrow morning, 10. Okay, thanks.
So I'm Tim April. I'm here to talk quickly about the DNS Transparency Project. Many of you are probably familiar about how DNS works. It's a pull-based system where there's no way to currently get a push-based notification to arbitrary end users without having to arrange something with the DNS provider. This means that any short-term changes in the DNS that aren't being actively monitored well will get missed, and there have been recent attacks. If you look at if you were to go and Google for sea turtle or DNS espionage, you can see a whole write-up on some of these attacks that took advantage of some of the weaknesses in the current model. This project is proposing to create a system where there's a push or generating a push-based model where we get data from registries and then propagate it out through a pub-sub sort of system to the end users that are interested. That could be a registrant, it could be a user, all sorts of things like that. This would get hopefully real-time updates from as many TLDs and then possibly later on second and third level domains as possible. And then it'll aggregate that and ship it out to whoever wants to get it in hopefully real-time or near real-time formats. There are a whole bunch of people involved. You can talk to any of us. I think there's only 2 of us here this week. About the 2 of us that are here will be here all week. We've also been working with some people from a couple different governments around the world to try and figure out what exactly the consumers need. And then if the things we're looking for right now, if you're a registry or a registry operator, we'd be interested to talk about possibly what we could do to get data. If you're a registrar or authority operators, we'd be interested to talk later on about how we can get some of your data. If you just want to see, we have a very simple web page up there, and we also have a form where you can fill out if you want to get more information as we get more data that ships out. We're in the process of trying to stand up or merge with or be taken under some other existing nonprofit and independent agency or independent organization so we can have an independent status and build something that's hopefully available to the community at large. And we're hoping to make it free to end users. So there's the link. If you have any questions, find me this week. I don't want to stand between you and dinner.
All right, thank you. So the last session, last talk is mine. So I know some of you know about this and been participating in it, but not everybody maybe. So this is kind of a hobby, little side project I've been doing at IETF meetings, which is to try to do a little social event that's modeled on the SIGCOMM Outrageous Opinion session. And it was the idea is to do some satirical talks. I was calling it Bad Idea Pechakucha for a while, trying to generalize it to not strictly be Pechakucha format. We've got several folks signed up now, and I saw a few come into my inbox during the session, so I think the list is growing. It's Thursday night at 9:30 in Duluth, which I think is the room right next door to here. If you're interested in giving a talk, you can do a Pechakucha, which is a very structured 20 slides. Each slide is up for 20 seconds, should be mostly text-free. Yeah, or you can just do a short lightning talk. Has to be less than 7 minutes. And the way to get time on the agenda is to send me an email with a talk title. And then I need slides by 6 o'clock on Thursday. So everybody's invited. There will be some beer, and I hope to see you all there. And thank you for coming here. If you have feedback about this or the Pet Kucha talks, please send me an email. I'm always happy to get feedback. So thank everybody. Go have dinner and enjoy the week.
I saw that. I completely agree.